For some problems, the u to the n and its derivative are not obvious in what's given. We use an alternative technique called substitution, in which we will create a u to the n and a du dx. In order to use substitution as a technique for integration, I've written out some steps for you. The first thing you're going to do is let the u equal the quantity that's inside the power, just the inside part. Do not include the power. Then you're going to find du dx. You're going to find the derivative of whatever you said u equals. You're going to make sure your problem has exactly u and du dx that you found. Then you're going to substitute the u and the du dx into the original problem and integrate it. After you've done your integration, you back substitute what the u was originally to complete the problem. For our first example on using substitutions to find an integral, we have the integral of the quantity x squared plus 5 being raised to the third power times x dx. So the first thing that we do is we let u equal the quantity that's being raised to the power, just the inside part. So the u will equal x squared plus 5. If that's true, then du dx, the derivative of the x squared plus 5 would be 2x dx. The problem is when we look at our original problem, we just have a 1x dx and not a 2x dx. So what we do to accommodate that, I'm going to rewrite the problem. The quantity part is okay. We don't have to worry about that. It's the outside part that's not right. So I'm going to force a 2 into that. But now I've changed the value of my equation. So to offset it out front, I'm going to multiply by its reciprocal, because 2 times 1/2 is 1. So I've taken this original problem times 2 new numbers, the 2 and the 1/2. It looks different now, but it's still equal to what it was originally because I took it times a 1. The bonus of rewriting it this way is now the 2x dx is exactly what I said my du dx equals. This allows me to do the substitution that I need to do. So when I'm doing my substitution, anything that I have had to tack onto the front, I have to keep. So I have to keep the 1/2. The x squared plus 5 is our u. It's being raised to the third. And 2x dx is exactly du dx. Now I have a simple single term to do the integral for. So keep your 1/2. Do the power rule, where you add 1, put it over the new power, plus c. So now we have 1/8 times u to 4th plus c. We are not done until we put back x variables instead of u. So we take out that u and replace it with what we said it was originally, the x squared plus 5. That's being raised to the 4th plus c. On example B, we have the integral of the quantity x minus 1 times the quantity x squared minus 2x plus 5 that's being raised to the fourth, and all of this is dx. So the dx, remember, is just there to tell me that the derivative variable that I was using was x. What might be a little helpful on this one is to put the quantity that's being raised to the power out front first. So I'm just switching the orders of the quantities, and you'll see why I did that as we move forward. Remember that you let u equal just the quantity that's being raised to the power. So just the inside, x squared minus 2x plus 5. If that's our u, then du, the derivative of that, would be 2x minus 2 dx. We write dx on the end to show that what we did the derivative of on the right side was an x variable. When I look at 2x minus 2, that does not match the ending part of my original problem. But if I factor a 2 out of that, I would have 2 times the quantity x minus 1 dx. Now I do have x minus 1 dx, which is in my original problem. What's wrong with it is that my derivative for du has a 2 in it. My original problem does not. So just like we did before, we're going to rewrite the problem, but now we're going to force a 2 in there where we need one. But since I took this thing times a 2 to offset it, I need to take it times its reciprocal. So I really have taken the entire thing times a 1. It looks different, but it's still equal. Now everything matches the way I need it to match. So I'm going to keep my 1/2 on the front, and I'm ready to substitute. I take out the big long quantity and replace it with the u, keep the fourth power. Now the 2 times x minus 1 times dx is exactly what du equals. So the du replaces all of that. So this du is on here just to tell you that this thing is already a derivative. When you find the antiderivative for it, you stop writing du or dx because it's no longer a derivative. We have a single term to a power, which we can use the power rule on. Keep your 1/2, add 1, so it becomes u to the 5th, over the new power is 5. Don't forget your plus c. So now we've got 1/10. We need to take u out, replace it with what it's equal to, x squared minus 2x plus 5, being raised to the 5th, plus c. You no longer have a dx in there anywhere because what you just wrote is no longer a derivative. It is now the original function. On example C, our integral is 7x cubed times the square root of x to the 4th plus 6. Recognize that a square root is a 1/2 power. So we've got x to the 4th plus 6 to the 1/2 power. And then we've got our 7x cubed dx. The inside of the parentheses is what we let our u equal. So it's just the x to the fourth plus 6. This then would make our derivative du be 4x cubed dx. When we look at our original problem, we have the x cubed dx. We've got a 7 in there that we don't need. So the first thing we're going to do is pull that 7 all the way out front. We need it out of the way, and anything that you need out of the way, you can pull out front. Then, to make our derivative portion exactly what it needs to be, we're going to force in the 4x cubed dx. We're forcing in the 4. But to offset that out front, we need a 1/4. So now what we have at the end, the 4x cubed dx, exactly matches what our du is. By putting the 1/4 out front, we have taken the whole thing times a 1, and it's still equal to what we had originally. We're ready to do our substitution. 7 times 1/4, we're going to make now a 7/4 out in front. Then the quantity gets replaced with u to the 1/2, and 4x cubed dx, the entire thing gets replaced with du. Now we have just a single item raised to a power. We can do our power rule. So keep your 7/4, keep your coefficient, add 1. 1/2 plus 2/2 gives us 3/2 as our power. And we put that over that power we just created, plus c. Dividing by the fraction of 3/2 is the same thing as multiplying by the fraction of 2/3. U to the 3/2 plus c. Multiplying the 7/4 times 2/3 would give you 14/12, but that simplifies to be 7/6. Take out the u and replace it with what it was originally, x to the 4th plus 6, being raised to the 3/2 plus c. Example D, we have x squared dx over the quantity x cubed minus 1 that is squared. The first thing you have to recognize is that we can't do our substitution technique when our quantity to the power is in the denominator. This means the first thing that we have to do is bring that quantity up to the numerator, but in doing that, we change our power to a negative. And then we've still got that times x squared dx. So for our substitution, we would let u equal inside the parentheses, the x cubed minus 1. This means then du is the derivative of that, which is 3x squared dx. If you look at our problem, we just have a 1x squared. So this time, we are going to leave our quantity alone. We have to now force in a 3 and then have our x squared dx, which we must offset with a 1/3 out front. Now our derivative portion matches what it should be. So we're ready to substitute. We're going to keep the 1/3 out front. We're going to replace the inside with the u to the -2, and then 3x squared dx. The entire thing equals du and gets replaced by that. Now that we have just a term to a power, we're going to keep the 1/3 out front. We're going to add 1. -2 plus 1 puts us at -1. Put that over a -1 plus c. Well, that over the -1 only has the effect of making the sign change. So we've got -1/3 u to the -1 plus c. We can't leave our problem with a u in it. We have to put back the x variable. So we're going to replace it with x cubed minus 1 to the -1 plus c. And if you wish to make this positive, you put it back into the bottom of the fraction. It would be -1 over 3 times x cubed minus 1 to the +1, which you wouldn't have to write, plus c. People often ask me where the integral symbol goes when we're doing this. Once you have added 1 and put it over your new power, you no longer have a derivative. The integral symbol is there to show you that what's following is a derivative. And once you've added 1, it's no longer a derivative. So that's why the integral symbol goes away. On example E, we have the integral of x squared minus 4x over the square root of x cubed minus 6x squared plus 2, and all of this is dx, so we're being told it's a derivative. Remember that a square root is a 1/2 power. And like the last problem, the quantity to the power cannot be in the denominator. So the first thing that we have to do is rewrite this as the quantity of x cubed minus 6x squared plus 2 to the -1/2, because we changed positions with it, times the quantity of x squared minus 4x dx. On this one, we are going to let u equal the x cubed minus 6x squared plus 2, because it's the part to the power. Then du would be 3x squared minus 12x times dx. But this does not look like what we have up above. However, notice there's a 3 in common in both of those terms. If I factor out a 3, I would have x squared minus 4x. So my quantity would match what I have up above, which means I need to force in a 3 and offset it with a 1/3. So I'm going to have 1/3 out front, the integral of my quantity x cubed minus 6x squared plus 2 to the -1/2 times 3 times the quantity x squared minus 4x dx. Now we're going to keep our 1/3. We're going to do our substitution. We're going to have u to the -1/2, and all of the rest of this, the 3, the quantity, and the dx equals our du. With that single term to the power, we're ready to do our power rule. So add 1 to -1/2. You will get +1/2, which you have to put over +1/2 plus c. Dividing by a fraction is multiplying by the reciprocal, so we're going to have 1/3 times 2 over 1 times u to the 1/2 plus c. 1/3 times 2 over 1 gives me 2/3. Take out the u, put in what it was originally. X cubed minus 6x squared plus 2 to the +1/2 plus c. Your other option is to actually put that into a square root symbol for the 1/2 power. So it'd be x square root of x cubed minus 6x squared plus 2 plus c. On example F, we have the integral of 3 dx over the quantity of 2x minus 1 being raised to the 3/5. You may or may not have noticed on example D, the dx was in the numerator. On example E, it was at the end of the fraction. And here on example F, it's back in the numerator. It doesn't matter which position it's in, it all means the same thing, whether it's in the numerator or tacked on at the end of the fraction, right beside the fraction. It all means exactly the same thing. So don't let where it's placed bother you. On this problem, again, we have a quantity in our denominator raised to a power. So our first step is to rewrite this as 2x minus 1 to the negative 3/5, since we've changed positions. And then we've got the rest of the stuff that we were already given, the 3 and dx. In this problem, we are going to let u equal the inside, the 2x minus 1. If that's the case, then du is 2 dx. The entire derivative for the 2x minus 1 is just 2. And then we have to say dx because our variable was x. What we need in our problem is a 2 dx. What we have in our problem is a 3 dx. So when we have a problem number, something that doesn't work for us, pull it all the way out front. Get it out of the way. We're going to leave the quantity alone. We're not going to mess around with it. And then we're going to force in a 2 in front of our dx so that we match. But if we're forcing it in, then we have to offset it with a 1/2 out front. Out front then becomes 3/2. We're ready to substitute. We're going to have u to the negative 3/5, and the 2 dx gets replaced with du. Because we have our single term to a power, we're ready to add. So keep your 3/2. For the u, negative 3/5 plus 5/5 plus our 1 is going to give us positive 2/5. Put that over your new power of 2/5 plus c. Again, we're going to multiply by the reciprocal of that fraction. So we've got 3/2 times 5/2, u to the 2/5 plus c. Our final answer then will become 15 over 4 by multiplying the two fractions. We're going to take out the u and replace it with what it was originally, 2x minus 1, to the 2/5 power plus c.